MCQ 23 is a salt preparation question. So employing the shortcut of salt preparation here is going to be that of a TempCap. So in TempCap itself, going through each of the method briefly, T represents titration, which is the use of an acid plus an alkali, often used to construct salts that are from group 1, very reactive and therefore require a neutralization to take place to create their salt, or it can be used to produce ammonium salts by itself. For AM, otherwise known as acid plus excess metal, we'll describe the class of metals to be used for this method later. Let's talk about Ca first, which is the use of excess insoluble metal carbonate plus acid. Now this method will be viable for CaP, which are known as the cap metals, the very unreactive metals like copper, silver, gold, and platinum. So that means that for AM, it's used for salts that are neither group 1, neither ammonium salts, or they do not belong to the cap salts of copper, silver, gold, and platinum. Now it's to note that this first three is only applicable to soluble salts. So it's imperative that prior to deciding on the methods to employ for salt preparation, you are familiar with salt solubility. Now P, which is the last method, applicable for insoluble salt. This would have been precipitation. And the method used over here is known as the NN rule. And the NN rule itself have us use sodium, something which is aqueous, plus something nitrate aqueous, and the act of swapping out the partners will have us end up obtaining sodium nitrate, a soluble byproduct, as well as an insoluble salt, which is the intended salt of preparation. And this could have been removed by using filtration, whereby sodium nitrate would have been the filtrate of the reaction, and the insoluble salt would have been seen as the residue. Now it's to note that for the case of here, these are all the recommended method. So if I were to give you titration, any salt that is due to be created by titration could also employ the methods of AM, as well as employ the method of Ca. But for the case of salts that is only applicable to go with AM, you cannot use titration to create those salts, but you could attempt to use excess insoluble carbonate plus acid. But for the case of salts that have to be created using excess insoluble metal carbonate, it is the only method that is viable to be used. It cannot be done using acid plus excess metal, neither can it be done by using a titration process. Now, some schools also give alternate method that instead of using excess insoluble metal carbonate, this method could be done using a metal oxide in excess plus acid. So with such a big summary, we are tasked to create a pure sample of potassium chloride. Now, potassium chloride, investigating its solubility, is actually an aqueous salt because all potassium salts are aqueous. So within T, AM, Ca, and P, I will have to rule out precipitation as a viable method. Now, taking into consideration that potassium is a group 1 element, that means AM and Ca is ruled out, we should have employ titration as a choice here. Now, titration involves an acid as well as an alkali. The back part of the salt is always derived from the acid. So the kind of acid that has chlorine, it will be HCl. The front part here would have been derived from the alkali. And with the alkali itself, we are looking for an alkali that actually has potassium with it, and that would have been your potassium hydroxide. So in A, this is the pair of reagents that we will be using in order to create potassium chloride safely in a lab setting. So although we could have used acid plus metal, this is quite explosive because of group 1 reactive nature. So we should not be using D because of this safety issue that is mentioned in this question.